Work, energy, and power are three fundamental concepts in physics that describe the interactions of objects and systems in motion. These concepts are interrelated and essential in understanding the behavior of physical systems. Work is defined as the product of force and displacement of an object. Energy is the ability to do work, while power is the rate at which work is done. In this lecture, we will discuss these concepts in detail, including their definitions, units of measurement, and real-life examples. Work. Definition. Work is defined as the product of force and displacement. When a force acts on an object, and the object moves in the direction of the force, work is said to be done. Mathematically, work can be expressed as W equals Fxd, where W is the work done, F is the force applied, and d is the displacement of the object. Units of measurement. The SI unit of work is the Joule, J. 1 Joule is defined as the work done when a force of 1 Newton, N, is applied over a distance of 1 meter, M. Other common units of work include the calorie, Cal, and the kilowatt hour, kWh. Example. A person lifting a box from the ground to a table is doing work. The force applied is the weight of the box, and the distance over which the force is applied is the height of the table. Applications. Work is a fundamental concept in physics and has many practical applications, including lifting and moving heavy objects, such as boxes or furniture. Pushing or pulling objects, such as doors or carts. Using tools, such as hammers or screwdrivers, to perform tasks. Operating machines, such as engines or generators, to produce energy. Daily life examples. Here are some daily life examples of work. Carrying groceries from the store to your car. Climbing stairs or walking up a hill. Vacuuming or mopping the floor. Shoveling snow or digging a hole. Pushing a lawnmower or a shopping cart. Energy. Definition. Energy is defined as the ability to do work. Energy can exist in different forms, such as mechanical, electrical, thermal, nuclear, and chemical. The total energy of a system is the sum of all its different forms. Units of measurement. The SI unit of energy is also the Joule, J. Other common units of energy include the calorie, Cal, and the kilowatt hour, kWh. 1 calorie is defined as the energy required to raise the temperature of 1 gram of water by 1 degree Celsius, while 1 kilowatt hour is the energy consumed by a 1 kilowatt appliance in 1 hour. Example. A roller coaster at the top of a hill has potential energy due to its height, which can be converted into kinetic energy as the roller coaster moves down the hill. Applications. Energy has many practical applications, including powering machines and devices, such as cars, computers, and smartphones. Generating electricity from renewable sources, such as wind and solar power. Heating and cooling buildings using energy-efficient systems. Providing light and heat through various forms of lighting and heating technologies. Facilitating chemical reactions, such as combustion or photosynthesis. Daily life examples. Here are some daily life examples of energy. The kinetic energy of a ball rolling down a hill. The potential energy of a stretched spring or a raised weight. The thermal energy of a cup of hot coffee or a warm blanket. The electromagnetic energy of a radio or a television. The nuclear energy of the sun or a nuclear power plant. Power. Definition. Power is defined as the rate at which work is done. Mathematically, power can be expressed as P equals W, T, where P is the power, W is the work done, and T is the time taken to do the work. Units of measurement. The SI unit of power is the watt, W. 1 watt is defined as the power required to do 1 joule of work in 1 second. Other common units of power include horsepower, HP, and kilowatt, kW. Example. An electric motor that lifts a heavy load to a certain height in a short amount of time has a higher power than a motor that takes longer to lift the same load to the same height. Applications. Power has many practical applications, including measuring the output of machines and devices, such as engines, motors, and generators. Calculating the energy efficiency of appliances, such as refrigerators and air conditioners. Evaluating the performance of athletes, such as runners and cyclists. Monitoring the energy consumption of households and businesses. designing and operating energy systems, such as power grids and renewable energy facilities. Daily life examples. Here are some daily life examples of power. The power output of a car engine or a generator. The power consumption of a household appliance or an electronic device. The power output of a car engine or a generator. The power consumption of a household appliance or an electronic device. The power output of an athlete running or cycling. The power capacity of a battery or a solar panel. The power output of a wind turbine or a solar panel system. Relationships between work, energy, and power. There are relationships between work, energy, and power that are important to understand. When work is done on an object, energy is transferred to or from the object. The amount of energy transferred is equal to the work done on the object. Power is related to work and time, and a high power output means that a large amount of work is done in a short amount of time. Example: a light bulb with a higher wattage, power, produces more light, energy, than a light bulb with a lower wattage for the same amount of time, work. In summary, work, energy, and power are fundamental concepts in physics with many practical applications in our daily lives. Work is the force applied to an object multiplied by the distance over which the force is applied. Energy is the ability of an object to do work, and power is the rate at which work is done, or the amount of energy transferred per unit time. Understanding these concepts can help us understand the world around us and make more informed decisions about energy use and efficiency. Conclusion. In conclusion, work, energy, and power are fundamental concepts in physics that describe the behavior of physical systems in motion. Work is the product of force and displacement, energy is the ability to do work, and power is the rate at which work is done. These concepts are applicable in many real-life situations, such as lifting weights, rolling a ball down a hill, and climbing stairs. Understanding these concepts is essential in solving physics problems and gaining a deeper appreciation for the world around us. Work, energy, and power are three important concepts in the study of physics. They are used to describe various phenomena in the physical world and help us understand how objects move and interact with each other. In this lecture, we will discuss the definitions of work, energy, and power, and their relationship with each other, along with some examples of how they manifest in our daily lives.